We do have the chat box here. Go ahead and put it in there. If you have questions throughout the webinar, just put them in the chat box and I'm going to monitor it and bring them up during our talk. You can go to the next slide here. Okay, and for those of you that don't know me, I'm Megan Pistoles. I'm the Education and Outreach Coordinator for the St. Lawrence Eastern Lake, Ontario Partnership for Regional Invasive Species Management, SLELO PRISM for short. We are one of 8 PRISMs that span the state of New York, creating a network of partnerships as an integrative approach to invasive species management. We're stemmed from the recommendations from the New York State Invasive Species Task Force. The PRISM network began in 2008 and became fully established in 2013. The network is funded by the Environmental Protection Fund in coordination between the Department of Environmental Conservation and various host organizations. SLELO is hosted by the Nature Conservancy, and we collaborate with our partners to reduce the spread and impacts of invasive species. Next slide. Today we're going to learn all about Asian jumping worm and ways to help stop its spread. But first I wanted to begin by showing you this map from imapinvasives.org. For those of you who are not familiar with IMAP, it's an online geographic information system database, and it's used to report invasive species observations to help land managers and conservation organizations strategize outreach and management initiatives. So this map shows 3 confirmed observations circled in yellow and 2 unconfirmed reports for Asian jumping worm that I captured from the live IMAP yesterday. And as you can see, there are reports for the jumping worm in the northern part of our region, in St. Lawrence County and Colton, and down in the southern portion of Oneida County. And it's likely that there are more infestations of this invasive worm that just haven't been detected or reported as of now. Next slide. Which is why I wanted to let you know about an IMAP Invasives Challenge that's going to be held June 24th through July 8th. And there's a webinar on June 24th to teach you how to recognize and report Asian jumping worm and other invasive species of interest to the IMAP Invasives database. And you can register for that right on their website there, imapinvasives.org, and just go to their webinar trainings tab on the menu. So now I'd like to welcome our speaker, Anise Dobson, who is originally from Ontario, Canada. She did her PhD with Dr. Bernd Blasi at Cornell. Now Anise is a postdoc at Yale University, working in New York City parks and natural areas, studying jumping worms and other stressors to forest plant communities. She is also working with the New York Invasive Species Research Institute and the New York Partnership for Regional Invasive Species Management, also known as the PRISM Network, to address invasive worm invasions. Thank you, Anise.
All right, thanks. It's great to be here. I was just taking a peek at the chat, and it looks like we've got people not just from this PRISM, but from Minnesota and from Maine, so that's kind of exciting. So what we're gonna do is, if you have any questions, just put them into the chat box, and Megan will sort of take a look at them, and if there's some that are particularly relevant, then she'll interrupt me to ask them as we go. But otherwise, there'll be some time at the end to ask questions, and if we don't get to your question, feel free to email me. My email is down there below. How's my audio?
You're golden.
Okay. Great. And if there's any kind of interruption, I think that just give it a little bit of time and I should pop back up. If you don't see me for 5 minutes, then you can be worried. Okay. All right. So you're probably, many of you here because you think a little bit about invasive species. And when we think about invasive species, we often think about the most visible species. So things like Japanese stiltgrass here that are just really striking in the forest when you see them. But there's another suite of invasive species that don't get as much attention because they are not so visible. And they only become important for what we think about when we see their impacts. And so invasive earthworms are one of those species that I consider drivers of change in an ecosystem, as opposed to some some more visible things like some invasive plants that might be passengers of other change, such as from earthworms. So you might be surprised to know that almost every earthworm that you see in New York and Minnesota and Maine are going to be non-native species that are coming over from Europe and Asia. So up here we have a picture of North America, and this purple blue line here represents the extent of the last glaciation. And so what we think happened is if there were any earthworms up here in northern North America, they were wiped out by that. Now in the pink here, you see the extent of native earthworm communities in sort of the southeast and some patchy spots of endangered prairie earthworms out here in the Midwest. And this is actually not that updated of a map. There are some native species that we've found in some places in the Northeast now. So there's small little pockets of them up here. But at least for the last 11,000 years, our forests have developed without earthworms. And so almost every earthworm that you see in the forests of New York and New England are going to be non-native species. And so I call the movement of these invasive earthworms into the rest of the world global warming, which is kind of cute. And so there's two different things that are happening. One that's relevant to the northeast of North America is that they're moving into previously earthworm-free areas. But around the world, they're also displacing native earthworm communities. And there's this whole beautiful diversity of earthworms around the world, from this giant one in Australia to this royal blue one also in Australia. And another interesting dynamic up here in the Northeast is that Asian jumping worms that have moved in are displacing some of the previous invasive European species. So there's all sorts of interesting dynamics going on there. One of the people to sort of get people interested in earthworms was actually Darwin. In this book that he wrote, this was the last book that he wrote, and it was one of his greatest hits. People really, really enjoyed it. And before this, people didn't really know what earthworms were doing. They thought maybe they were pests. And he observed them really, really carefully and actually found that what they're mainly doing is mixing and mineralizing, so breaking down organic matter in the soil. And so you might be wondering, okay, Darwin studied them, they were great. I've always thought that earthworms are wonderful. I see in the chat box lots of positivity about earthworms. And that is certainly true in gardens and farms with some species of earthworms, but it's definitely not true in forests. And so you have to, not every species is going to be good in every case. Right, so over here on the left, we've got the farm that I grew up on here in Ontario, and those soils, they get plowed regularly. You plant fast-growing annuals in that are just usually growing for a season. And if the plants have any nutrient deficiencies, you can amend them with fertilizer and things like that. But the plants in the forests have evolved under completely different conditions. So slow soil mixing, slow growing perennials, and they can't just rely on getting fertilizer amendments. They have to associate closely with other organisms in their ecosystem to get nutrients and spread seeds and things like that. So what happens when earthworms move into an ecosystem? On the left here, we have sort of an intact native system, and you have leaves that grow on trees, fall down to the ground and decompose quite slowly and stay close to the surface where all of those beautiful native plants we love, trilliums, and we've got geraniums in here and various things. And there's a really rich soil fauna community that's living in the really duffy layer below that. When earthworms move in, they mix that all up and change it to a much more homogeneous condition. And jumping worms in particular, what they do is create a really, really dry, gravelly surface on the top instead of this nice, soft, nutrient holding layer. So if you want to look for the the differences between jumping worms and European species. The main thing is their behavior. So this is definitely slowed down, but on the left here with jumping worms, they writhe back and forth, whereas European species, they move by expanding and contracting their setae. Jumping worms also stand out by having really, really high density that you'll notice in August, September. They get to maturity really quickly. They are parthenogenetic, which means they don't need to reproduce with a mate. They can just create copies of themselves. So just one is enough to reproduce. And they reproduce really prolifically. So their population can grow much, much faster than the European species. So these jumping worms are from East Asia in origin, so Korea, Taiwan, Japan. There's 16 species that are in North America, 5 species that are considered quite invasive, and 3 of those are really common in the Northeast. But remember at the beginning I was mentioning that they didn't really garner a lot of attention because they're moving through the soil. People aren't really thinking about earthworms, but people on the ground notice their impacts. And so because of kind of this bottom-up observation of their impacts, they have a ton of names in North America. So this is just a small selection of them you might have heard of. Jersey wigglers, Alabama jumpers, Georgia jumpers, all of those are inaccurate in their location names. Snakeworm, crazy worm, Asian worm, and then the scientific names, megascalescid and pheretymoid that you might also hear. So these 3 species that we have are Amenthus agrestis, Amenthus tokyoensis, and Metaphyre hilgendorfi. And they can be quite hard to tell apart. So for most purposes, you can just consider them all jumping worms. And in the Northeast, so they were observed in greenhouses and zoos in New York City in the 40s, but only observed in the wild in the 1980s in New York City. And this map, I think, is really, really interesting. So this dark gray that you see here, that is, those are regions that jumping worms could grow based on their physiological conditions. So you could, in theory, they could survive up here, like within range of Hudson's Bay. But these little points here in black and gray, that's where they have been observed. And what's really interesting to me is that you see, we've only found 1 sighting in Canada, and it's right here on the border. And that's not because they can't grow here. It's because there's such limited movement of soil and of plants and things like that over the border. So it's kind of unique for an invasive species to actually be able to control it by preventing the spread. Right, so some of the early observations in Washington, D.C. in 1912, there's some stories that they came over in these plantings of the Japanese cherry trees for the Cherry Blossom Festival. There's some pictures when the platypuses came to the Bronx Zoo that they were kind of experimenting with what to feed them, and they found that they really liked jumping worms, so they were growing them there. And I do a lot of work in the Bronx, and they're very, very prolific there. But even in Albany in 1948, there were some found in some peat moss that are florists. So they've been around for quite a while, but they've only become quite problematic fairly recently. And so I mentioned before that I'm doing a lot of work in New York City. And just to give you some context, they were sampled back in 2013, 2014, and 12% of the nearly 2,000 plots had jumping worms. 5 years later, when I went to look at them, it was up to 64%. So that is pretty fast-moving, prolific invasion. And there's some parks that they've gone from 5% coverage to 100% in that time period, including some of the really gorgeous, more native vegetation parks in New York City. In New York, they are a prohibited species. And so what that means, I tried to find this earlier today. So for the general public, if you're found transporting them, not if you have them on your property, that's fine. That's just if you're transporting, you will first get a warning and you can get a fine. For nurseries, it's a little bit more serious, first you get a warning and like some information about it. You can get a fine with a pretty hefty minimum. And in theory, though, I'm sure this has never actually happened yet. You can have your nursery, your business, your nursery license and certificate revoked potentially for selling these things and not knowing, selling these things knowingly. And some counties have additional penalties on top of that. All right, so that's kind of a background, and I'm going to talk about some of their impacts. So this here is just like a little picture of the ecosystem that we might have in some parts of North America. So you've got plants and primary producers, you've got herbivores feeding on them, you've got carnivores eating those, and then top carnivores eating those. And when you think about jumping worms, they're not just impacting any one level of this, their impact goes all the way up to all of these different levels. And I'll just talk about a few of them. There's many more that I could discuss if you're interested. But the main impact that they have is by consuming all of those leaves and all of that organic matter and turning it into this gravelly soil. And so that's like one of the first things that you'll notice. This exposed mineral soil that's really crumbly, looks gravelly. Some people have called it looking like coffee grounds, whatever you want to name it, but there are these big chunks that are really, really crumbly, and with that comes some pretty heavy duty erosion that happens. So that's a really good thing to look for all year round.
Anise,
And what that, oh yeah.
there's a good question about impacts.
Great. What do we got?
So we're curious, do Asian jumping worm have similar densities and impacts in their home environments, or is there something that restrains them in their home environment?
You know, that's funny. I had that exact slide in here and I moved it out of the talk. So how about I will promise to mention that at the end of the talk, because I do still have the slide in here. I've got like, I've got the end slide and then I've got a bunch of slides after that. So we'll get to
problem.
That. It is a really good question and there's a surprising answer, so stay tuned. All right, so what the consequences for plants are then is this soil that is really, really hard to grow. And imagine you're trying to grow plants in gravel, essentially. So there's low germination, the roots, there's a lot of root desiccation, so drying out of the roots, especially if you're doing landscaping and plants are coming in and they're new and being established. And plants can just topple over because it's so unstable. And what this means when you think about some of the other stresses that we have in New York State, jumping worms come in, and some plots that I had with jumping worms and with heavy white-tailed deer browse pressure, I found that in a really, really short time span, you can completely lose some populations of plants. So complete local extinction in a really, really short time. And you also see impacts. This has been gaining a lot of steam because it's not just forests that are seeing the impacts. I've had emails from a lot of parks, soccer field, parks with soccer fields, golf courses, that have found that their grass just starts dying from jumping worms. And so this is starting to not just be a conservation issue, but a real economic issue in New York State. One thing that seems to impact how affected a plant is, or how it roots. So things like this Johnny Jump Seed, which is native, and poison ivy, which is also native, they're okay rooting in unstable soil. So Johnny Jump Seed, if you've ever seen it, it grows up, it can fall down, and then that stem that was growing can become a root, and shoots will come up from that. And poison ivy it has a root that grows just along the surface and sets down little roots below that wherever it can. But poison ivy seems to be doing just fine with jumping worms. On the other hand, things like true Solomon seal and trillium that have these big storage roots seem to be really, really hard hit by these changes in soil. And we think that there's a few other things like plants that rely on the whole food chain and on the whole ecosystem for things. So things like ants that disperse a lot of the seeds of spring ephemerals are affected when you lose the duff layer and when the top of the soil gets really dry and hard to live in. And the same thing for some of the fungi that you may have heard of that plants associate with to get nutrients. And so, like I said, this, this goes everywhere that you look. This here is a picture of the density you might find of jumping worms on like a damp summer morning. So they're quite dense and they can live right at the surface, but negatively affecting some of the soil community, which those soil community provides food for birds and salamanders. And the jumping worms are, you'd think maybe that would be good food for plants and for animals, but in fact, they're quite full of toxic metals. And the fact that they appear so quickly and then disappear so quickly mean that they're not a stable food source. And additionally, their impacts of promoting invasive species that are not good for birds and limiting native plant species that are good for birds. It's not a good thing. So you may want to ID I've seen some information in the chat. People want to know how to ID them. So one thing you can do all year round is look for that soil here. So starting in January, when the snow is gone, you can see that coffee ground soil is really visible. And you can, if you look closely, see the cocoon. So they look like a little piece of osmocote or slow release fertilizer in the soil. Right now where we're at, they are juveniles. And so you can sort of tell that you have them. They're pretty small, really quite small. But they're all about the same size. And they have that really crazy thrashing motion already. But it's really in July, August, September, and into early October that you can definitively say that you have the adults. But really, if you see the soil, you can be pretty sure that you have them. So the soil in an uninvaded system that you might see in a lot of the Adirondacks and places like that, it's got this deep organic horizon, great for native plants to grow. European species is going to be looking homogeneous, kind of like this in the middle. And then with the jumping worms, that's where you get the coffee ground gravelly soil. So if it is late summer, early fall, you can find the earthworms. If it's a damp enough morning, they'll be right on the surface. And you can look at their activity. So on the left here, we've got the jumping worms. You can see them sort of slithering quite like a snake. And then on the right here, we have the European earthworms that are moving by expanding and contracting, expanding and contracting. If it's drier out and you think you have them, but they're not right on the surface, or if you want to be quantitative and see how big the population is, you can do this mustard sampling. So a third to a quarter cup of ground mustard, just like Coleman's mustard or something like that, mixed in a gallon of water, and then you pour it slowly over the soil, and that will pop the earthworms up. And then you can look at their behavior and look for some other distinguishing features. If you really want to get a species ID, I know that there's some people that need to get down to species. You can fix them in formalin and then put them into ethanol and contact me, and I can give you some information about how to ID them. So when they're big and they get really, really big in the summer, and that's probably when you'll be noticing them. So they can be, 20 centimeters long and as thick as your pinky finger, which is about the size of the nightcrawler, the European nightcrawler. But you probably want to tell them apart because they are a little bit tricky to distinguish, and they are both quite dark in color, but the jumping worm, it has sort of a quite metallic sheen, and the nightcrawler is specifically dark at its head and turns quite light at the tail because it's in these deep vertical burrows, so it only needs melanin in the head. Another really distinctive feature is the clitellum. So that's the female reproductive parts here in the middle. On the jumping worms, it's going to be often cream color or light pink color. So that can be different with different things. And it's a little bit, it's kind of flush with the body, kind of like a corset almost. You can think of it that way. And it goes all the way around. So it's exactly the same all the way around. And so if the jumping worm has a corset, the European worm has sort of a life jacket. So it's sort of a saddle-y type clitellin that's bigger on the back and smaller on the stomach, like in this picture here, you can see. And the other thing that I look for really, really quickly is that the clitellum in the jumping worms is quite close to the head. So it's in the first sort of 10% of the worm, whereas in the nightcrawler, it's closer to the middle, sort of in just the top third of the worm. And so if you observe jumping worms, or importantly, if you don't observe them and you're out for a hike or want to log this in, we would love that information for IMAP invasives. And I'm actively using that to get a sense for how jumping worms move, both at the local scale and at the sort of regional scale. Okay, so what can you do about it? You guys are really interesting because the jumping worms are not at all widespread. So you have the chance to have some real impacts. So historically, golf courses have been working at how to limit earthworms moving into golf courses, more for sort of aesthetic and recreational reasons than ecological. And they had some pretty good success with some mercuric chloride and lead arsenate and sodium cyanide. But as it turns out, that's not really great for human health, wildlife health, water health. So definitely don't use that. Some people will use saponins. So this is it's a fertilizer or an amendment that it's organic. It's from seeds. So like if you cook quinoa and there's that bubbly detergent-y like stuff that bubbles off of it if you haven't rinsed it enough, that's what this is. And so people are using that even though it is not what it's been approved for. So this company is really uncomfortable with that use. It hasn't been tested, it hasn't been approved. So it is pulling some of those products. And I think that is, not wholly unreasonable because we don't, even though it's organic, doesn't actually mean it's safe. Could definitely get into the water. We don't know what it means for fish, for aquatic habitats, and it does require reapplication. But there are some people out at the University of Wisconsin Arboretum, and they are really looking into some of these properties and doing some great science. And so their stuff is hopefully going to come out really soon to know if this is a good option. But for now, I would not recommend this unless it's in like a small area that's contained and isn't going to get into the ecosystem. Biocontrol options. This is an idea that works for a lot of things. However, there's already a lot of things that eat jumping worms. The problem is not that they don't have predators. They've got plenty of predators, but they just are so prolific at growing that there's always new individuals to replace those that are eaten by predators. There is some work by Joseph Gores at the University of Vermont on some fungal pathogens that is promising, but biocontrol stuff takes years and years and years. So I would not be holding out for hope on this anytime soon, particularly because I mentioned at the top that we have noticed that there are actually a number of native species that are relatively rare growing in North America that we didn't know of before. So that makes any management particularly tricky because it's very hard to tell one earthworm from another if you're managing for them. Sulfur is one that I've also heard people mention. This is another one that I would not recommend. The idea is that you lower the soil pH to make the conditions less ideal for earthworms. And it's true that that does lower the population of jumping worms, but along with that are going to be all of the other consequences of having acidic soil. And so I think that this is a case of missing the forest for the trees or something like that. But things that you can do. So one of the main things, you guys have a lot of fishing industries up there. And so that's a really important one to go for. jumping worms are often in bait along with those night crawlers. They seem like they're big and juicy and good, but they actually are quite bad for fishing. They don't stay on the hook. I've heard from many, many fishermen that they don't like them. So I think that this is a great opportunity for you guys to push for your fly fishing. For your Adirondack fly fishing. That's a much better option for invasive species. Planting bare root is a really, really good idea, especially if you're a nursery that already has jumping worms. Then this can be a way of being sure that you're not going to get some of those fines that I mentioned early on. So eggs, so you can look at the roots and make sure that they're relatively clear of soil, and you can see the eggs of the jumping worms with the native eye. So if you do like a visual inspection of the roots, then that should be suitable. One other thing to think about is not buying jumping worms from compost. Just like the fishing, they seem like they'd be good for it because they're big and active, but they're much, much less good than the red wrigglers, which are also invasive species from Europe, but they are better at composting and they tend to stay closer to the compost pile. And they won't move out into the woods and cause as much damage as jumping worms, but still best to keep them contained. One thing you can do to identify that they're the red wrigglers is that they have these these yellow bands between the segments that you can see, especially if you sort of hold it and sort of pull the earthworm out a little bit. One way that I see jumping worms moving a lot in the Finger Lakes region and now also in New York City is from people dumping their yard waste. So you might see a place that is full of plastic trash in New York City and it won't have jumping worms. But then you see a pile of clippings and bits of lawn mowed material and things like that, and it's just full of jumping worms. It's the perfect habitat for them. So just make sure that you're not dumping those into the woods. If you're buying mulch, topsoil, and compost, you want to give a little bit of thought about where it's coming from. So technically, if you're buying these things, they should be heat treated to, I think, 130 Fahrenheit is what they should be treated for. But that's not always the case. And sometimes if you have a bag of it that has been treated, it's then sitting around and can accumulate more invasive species. So that's something to keep in mind. If you buy any of these things and you're concerned that they might have jumping worms, those folks I mentioned at the Wisconsin Arboretum, they found that just 104 Fahrenheit, which you can get up to if you're solarizing or have like some kind of small oven or drying oven, you can get to that relatively easily for 3 days. And that's enough to kill the eggs and the adults. So that's not good enough for the air temperature, but the temperature of the soil needs to be that. So that's one thing that you can do. But better still, make your own mulch, make your own compost, do it on your own property. When we had a tree cut here in our yard, they, for very low cost, or in this case for free, they would chip up the mulch and they were happy for me to keep it instead of having to cart it away. And so there might be an opportunity even for some additional businesses in that. Because you guys are up there, don't have the invasions like we do down further, having these sort of local supply chains, I think could be really, really, really valuable, not just for jumping worms, but for all sorts of invasive species that might come up in mulch. Learn to recognize the signs. So this is just a picture I've showed you a few times of what these metallic jumping worms look like with their creamy clitellums here very close to the head of the organism. And the gravelly soil that they convert it to. If you want to actually check for the jumping worms, you can do that in the summer and early fall. So that's the mustard pore that I mentioned. That brings the worms to the surface if they aren't already there. Logging and landscaping is a big one to think about. And I know that down here, I'm living in Connecticut, and there are a lot of homeowners that are requiring in their landscaping contracts or land trusts and things like that that have logging contracts. They're requiring that the machinery comes in clean. And I think that's a really, really good idea. If you just have a power washer as a landscaping company, just wash that off between places. But the earthworm cocoons are really, really, really easily moved in these big treads of tires. And then if you are a nursery or a homeowner and you're getting plants in from elsewhere, especially from further downstate, it's always good to check as it's coming in for any signs of the castings. And because there are these, legal protections from the state, I don't know exactly how that would work to potentially get your money back, but I think that there's probably a way to work with that. So you can sort of wiggle the plant out of the pot and look on the surface for those coffee ground-like castings before you plant them. And then, of course, log the presence and absence into IMAP to help us understand their spread. Now that you guys are all experts from your 45 minutes of jumping worm information, you can encourage your neighbors and your friends to be vigilant. I think the best way to think about this is that we're all in it together as opposed to pointing fingers. There's been some pretty ugly neighbor relationships down here in Connecticut that I've seen. There have been tears, there have been threatenings of lawsuits and things like that. And I think that if we take a mindset that we are all need to be vigilant in this together, I think that that's going to be our only chance of really having an impact on this. So also encouraging your professional organizations, your local government, your state government to support and lobby for research efforts on biological control and some of the other ecological impacts of these guys. And then another thing, so this stuff is all pretty new and I'm doing some experiments on their impacts, and a number of researchers are in the Northeast, but there's so much that we don't know, and so much of my ideas about what to study have come from people working on the ground. In fact, my whole impetus for studying this is because the Cornell Botanical Gardens was really on me. Like, I swear, for 20 years I've been seeing these worms, and people keep telling me that they are good, but I know that they're not. I see them killing the plants. What is going on? And so, also from the fishermen, that these don't make good bait. That's another thing. They've done little experiments like that. So if you have kids that are stuck at home, maybe over the summer, doing some kind of small scale experiment on the impacts, the spread, and the removal can be really, really helpful. And we can think about scaling that up to something bigger if you find interesting results. All right, so we'll come, I just actually want to give a little shout out to this article called Cancel Earthworms in the Atlantic. It's a long form piece. There was a journalist that was really good that came out and followed me around for two days in New York City. So that's definitely worth the read, and this awesome art that they made for it. But I will mention, we talked about, okay, then the native range. So we've got some colleagues that are in Japan that study these jumping worms. And it's so interesting how different it is. So first of all, they have 170 species, probably actually more like 200 at this point. They're always discovering new ones. So they've got a huge, huge diversity of them. And these 3 species that we have, the 2 amenthus and the 1 metaphire, they don't come into the forest. There's other worms in the forest, but these worms in the forest keep them out. So they're only in ditches and things like that. And so they have jumping worms here in the forest, but they're in such small abundances and different species that you still have species like things like these lycopods here. The same genus as the ones that we have over here, probably certainly different species, but they would never grow with jumping worms around here. So it is interesting that they have them, but the really bad ones are relegated to the ditches and the really disturbed areas. And the forests have earthworms, but in quite low abundances. All right, so that is all that I had for you guys. Megan, maybe you want to let me know if there are some good questions.
Yeah, I actually have a quick question on this, what you just shared. Is there a reason why the bad ones are kicked out of the forest in Japan? Or do we not know?
I kind of, yeah, I kind of.
They don't have a VIP pass, I guess.
I kind of left that up to. I didn't mention anything because it would be just pure speculation as for why they don't move into the forests. But one thing might just be that because we don't have native earthworms in our forests, it's like an empty niche for invasive species to come in. Versus there's already worms that are territorial or better competitors or whatever it is in the forest. So if you're thinking about the human body, and if you have like a good healthy microbiome, that's quite beneficial to keep out toxic microbes that come in.
Okay,
But that's just a wild idea.
Okay. Yeah, we do have another question that you didn't answer. Yeah. So you did go over some of the known, well, not known, but some of like the ideas for control and like ones not to use. But is there one that is like good to use, or is prevention really the only thing we can do right now?
Really, if you're talking about like a whole property, prevention is really the only viable option. Now, one thing that's nice is that they have really big boom and bust cycles. So they will often disappear on their own. And then the challenge for you is to not let them come back in. Like I said, a lot of them don't need to find a mate to reproduce. So just a single worm is enough to restart the population. But yeah, if you already have them in your whole property, there are currently not any options to get rid of them. But I would say that of these other options, probably this one, the saponin management, is the one that is going to potentially be, like some version of it might be viable in the near future, with some recommendations from these researchers at the University of Wisconsin. But yeah, if you have them, we currently don't have any way to get rid of them.
Except for maybe doing a lot of mustard drenches and plucking them out and like putting them in a bag and not letting them back out. It's labor intensive, but
it's very labor intensive, and if you have them in just a small area, that can be useful. But people have been, I've heard lots of reports of people that have spent the last 3 years trying to pick out every worm that they could find, and they haven't seen any reduction in the following year. So yeah, if you do have the option of a controlled burn, I didn't actually have this one in here because it's not so common in the Northeast, but prescribed burns that are timed right after the adults have disappeared that will destroy the eggs can actually be extremely effective. Yeah, so let's see. That's futile to pull them out. I tried and injured myself to no avail. That's in the comment section. I think I would agree with that. Like, I think that there's enough of them coming in that pulling them out is going to be pretty rough. And then I see, do the cocoon seed banks across? Do they seed bank across seasons? Yes, they do. So they can exist for more than 1 year. Unfortunately, I don't know how many. But definitely more than a year. And then we see a question, do you have any confirmed sightings on the West Coast? Yes, Oregon had some early on, but Oregon has some problems with them, but there are a number of states out west, such as California. California is actually the first place that they were seen in the late 1800s, but they haven't really expanded much, and I don't actually know why that is. I don't think anyone knows why that is. Why the Northeast seems to be The Northeast and the Southeast seem to be particularly hard hit. We don't know if it's like a lag that they just haven't been spread around as much, or if there's something that prevents them. All right, what else have we got here? Do the Asian jumping worms seem to be intensive in hot spots, or will they be intense over wide areas? Yeah, so I would say that they are different from invasive plants in that way. So invasive plants move kind of like a wave, and they spread through the air, and they're really, really hard to contain. But jumping worms, I would definitely say, are much more patchy. So they move. So I would say in probably your region now, if I were to guess, there's a lot, or not a lot, there's a number in sort of suburban areas and lawns, but that they're not very widespread in the woods. So yeah, I would say definitely it's a hotspot or a satellite situation. And then, are there soils / ecosystems that favor or disfavor their populations? That's definitely true. Unfortunately, the wet, mesic, beautiful, organic-y horizon forests are like the best place for them. Your Adirondack forest might be a little bit better off because they tend to be a little bit more acidic. So that kind of disfavors the population under trees like pine trees and coniferous trees, as well as rhododendron and things like that. So you can definitely have, depending on the litter quality, you'll have, and the moisture of the soil, you'll have more or less earthworms. What else we got? If anyone wants to unmute themselves and ask a question out loud, that's great too. Okay, so I see a question here. Once in the locale, do the questions get spread on boots, animal feet, water, runoff, etc.? Yeah, so I'm right in the middle of doing a study on that right now. What are the major spreaders of them? And I would say that water runoff, mulch, yard waste, and tire treads are the 4 biggest. Boots and animal feet, definitely possible. No reason it couldn't be done. But it's just much less of spreading than other things. And I would say, yeah, like landscaping and soil and topsoil are big ones. And then another question, don't they lay cocoons from April to frost? Yeah, so they, their life cycle, I think I have a slide about that I sort of zoomed through that we can go back to. So they mature really quickly. They can mature, so if they hatch here around mid-April, in theory, they can mature in 90 days from that, 60 to 90 days. So they could be starting to lay eggs in, mid-June and, sort of July. And unfortunately, with climate change, lengthening the growing season, they seem to be able to actually have a second batch of eggs. So 90 days from first hatching, and then those eggs can actually hatch another set. So yeah, so they're laying eggs really from mid-June, really July until frost.
Anise, could you mention when the best time of the year is to identify them? Is there a best time?
Yeah, so I would say August is really, August and September are the ideal months to check your property or to check property for jumping worms. October a little bit, July a little bit, but August and September are really the key months for looking for the worms themselves. And I see Rose Casperi says, asked me if I want to come to Poughkeepsie. I would love to come up for a visit. It's not too far from here. Shoot me an email after and I'll come up and take a day hike up there. Okay, in terms of general ecosystem disservices, is it fair to rank Asian jumping worms with intense deer overpopulation, but not something that can be remediated? Yeah, okay, that is a really good question. So where do jumping worms rank for the other stressors that are going on in the Northeast? Climate change, pollution, all these other things. I am, and so deer in particular, I'm studying their independent and their combined effects. And I would say that jumping worms and white-tailed deer are, in terms of total effect on plant populations, I would say they're about the same, but in slightly different ways. So jumping worms are impacting a plant's ability to germinate and to grow when they're small because they're drying out. Whereas bigger plants, and for all of you landscapers out there, if you're doing landscaping in a place that has jumping worms, a key thing is to choose bigger, older plants to plant in rather than smaller ones. Whereas the deer are going after the bigger individuals that are setting the seeds. So I would say they're both about equally bad, but when you have both, it's even just so much worse. This was another slide that I actually took out, unfortunately. But plants in New York City were able to withstand either jumping worms or deer pretty well, but when you had both, completely disappeared. So that was quite unfortunate. But yeah, as you said, it's much easier to hunt deer than it is to hunt earthworms. So I would say that if you do have an earthworm problem, hunting deer is not a bad indirect effect or indirect resolution. I'll have to add that on as a number 12 in the list of things you can do.
Excellent, thank you. Does anybody else have any other questions for Denise? Okay, well, that concludes our presentation for today. Do keep your eyes peeled for follow-up email in the next couple days here. I'll be sending out some resources along with these slides and a link to the recording. We'll also send out a Google form invitation just to kind of gauge the interest in possibly having an in-person, like in the field example of what the Asian jumping worm looks like. There, we wanted to visit one of the places that it's been reported and just have an in-person look at these worms, possibly in the fall, depending on how restrictions with COVID-19 pans out for gatherings. So just keep your eyes peeled for email. Thank you so much for attending, and have a wonderful day.